So in the previous part, we discussed how to solve the L2 regularized least squares problem, and we derived a closed form solution as well as a gradient descent update equation to get the optimal value of the parameters W to minimize the objective function, the L2 regularized least square objective function. And before we begin to optimize to minimize the L1 regularized least square objective function, it becomes important to know a bit about convexity, convex functions, convex sets, and subgradient algorithms. Subgradient descent algorithms and what subgradients are. But this part of the lecture is not important to be able to implement the algorithm. For example, if you just want to implement subgradient descent algorithm to solve the L1 regularized least square problem, or if you want to just implement the ISTA algorithm to solve the problem, it is not important to go through this part of the lecture. This part of the lecture is for those who want a very deep mathematical understanding as to how everything is derived, how everything is actually formulated. How do we come up with subgradient descent algorithm? How do we come up with an ISTA algorithm, which is much faster than a subgradient descent algorithm optimizing the L1 regularized least square problem? And also those who are planning to build a career in research in future, or those who are looking to solve real world industrial problems, they should go through this part of the lecture because it helps them to understand what is so special about convexity, what is so special about convex functions, the convex sets, and what the subgradients are. And when you're challenged with a new problem, perhaps if you're working in industrial robotics, autonomous driving vehicles, or if you're designing a totally new deep learning architecture, how can you design new algorithms, new cost functions that will help you to solve the problem much more efficiently, or have better accuracy at solving those problems or performing the tasks, basically, if you're working in industrial setting or trying to do a new research. Furthermore, if you're planning to build a career in research, it becomes more important to understand the mathematics behind everything. So this part of the lecture will now deal with convexity, and it will build the foundations to derive to understand the mathematics behind the derivation of the ISTA algorithm. So if you're just interested in the subgradient descent algorithm and the ISTA algorithm, you can skip many parts of this lecture. But if you are keen to know how the ISTA algorithm is actually derived, the very mathematics behind the derivation, then it's very important to understand what convexity are, the subgradient descent, and they will combine all the knowledge that we have provided in these particular following sections. How do we combine? We will combine all these knowledges to derive the ISTA algorithm. So let's see what is convexity, what convex functions are, what is convex set, and what are the various conditions for a function to be convex, and then finally we'll understand what is subgradient and how can we use it to minimize a convex function.